Hello, welcome to Lesson 7 of Unit 8. This is a Friday class since we do not usually have math class on Fridays. The lesson today is using histograms to answer statistical questions. Remember that a histogram is just a bar graph, so don't get afraid by that big word. It's just a bar graph. Alrighty, our learning targets are I can draw a histogram from a table of data, and I can use a histogram to describe the distribution of the data and determine a typical value of the data. Okay, 7.1 says, which one doesn't belong? Here are 4 questions about the population of Alaska. Which one does not belong? Be prepared to explain your reasoning. So number 1 says, in general, at what age do Alaska residents retire? Number 2 says, at what age can Alaskans vote? Number 3 says, what is the age difference between the youngest and oldest Alaska residents with a full-time job? And number 4 says, which age group is the largest part of the population? 18 years or younger, 19 to 25, 25 to 34, 35 to 44, 45 to 54 years, 55 to 64 years, or 65 years or older. Okay, so I want you guys to take a minute or two to think about which one you don't think belongs with the other questions and why. Pause the video while you're thinking and then unpause it when you are ready. Okay, so for this question, 3 of the 4 questions are going to give you data that has variability, meaning lots of different answers, and one of them does not. So the answer that you should have said doesn't belong should be number 2. Number 2 does not belong because likely that's going to be one answer. It's going to be something like 18 or 20. I'm not sure exactly when Alaskans can vote, but let's say the answer is 18. Your graph would look something like this, and all your answers would be in one spot, and so that's not really good statistical data. So that is the one that does not belong. Okay. (7.2) Measuring earthworms. An earthworm farmer set up several containers of a certain species of earthworms so that he could learn about their lengths. The length of an earthworm provided information about their ages. The farmer measured the length of 25 earthworms, so 25 is our sample, in one container. Each length was measured in millimeters. Using a ruler, draw a line segment for each length. Okay. So if you don't have a ruler, you can't do this, but if you do have a ruler, you're going to go ahead and take the ruler and measure out these lengths and just draw a line segment. So I don't know exactly how much that's going to be, but if you have a ruler, do that. If you don't, then don't do it. A says, here are the lengths in millimeters of 25 earthworms. So here are all, we have 6 millimeters, 11 millimeters, 18, blah, 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 blah. We can see our data has a lot of variability, which is good. It means it's good statistical data and that our graph is not going to just be one bar. Complete the table of lengths for 25 earthworms. So here it gives us a range of lengths, and then we need to fill in the frequency. So yesterday we started doing this. Remember that when you are dealing with frequency, it means you are counting the number of data we have in that range. So for example, 0 millimeters to 20 millimeters. Let's go through and highlight all that fit. We have 6, 11, 18, 19, I think that's it. So we would put a 4 under frequency because we just counted 4 lengths. Hold on one second, I'm having some technical difficulties with my Apple Pen. Okay, a 4 there. Now the next one says 20 millimeters to less than 40 millimeters. So let's go ahead, I'm going to highlight these in orange. We have 20, 23, 23, 25, 25, 26, 27, 27, 28, 29, 32, 33, and that's it. So it really helped for this one, for this problem, that these are actually in order. That's really a visual help for us. Let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to put a 12 under frequency. Okay, go ahead and do the rest of those on your own. Once you're done, go ahead and keep going with this video. What you're going to do now is you're going to take that information and you're going to draw a histogram. So our histogram here is already set up with labels. So as you can see, the bottom is going 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The bottom axis is going to be representing length of earthworms. And then this axis is going to be representing frequency. So you're now going to take what we've done and you're going to graph it. So for example, the first table, 0 to 20, is going to be these first two lines. And we know that we had a frequency of 4. So you're going to go ahead and color in for both of these two all the way up to 4. And that would be your bar for that one. For 20 to 40, we counted 12. So now you're going to go ahead and color up to 12 for that, for those two lines. And you're going to keep doing this with the rest of the data that you collected on your own. And then go ahead and unpause the video once you're done. So then you have some questions to answer about your data. It says, based on the histogram, what is a typical length for these 25 earthworms? Explain how you know. So remember, when it asks typical length, it's what is common. And you don't want to necessarily say the one that has the most, but you want it to be somewhere in the middle of your data, somewhere around where there's a lot of answers. So I'm going to let you guys answer that question on your own. But for number 4, write 1 to 2 sentences to describe the spread of the data. Remember, by that, it means like if you took butter and you spread it along a piece of toast, is the butter all clumped on one side? Is it clumped on the other side? Is it evenly spread throughout? How does your data look? Is your data clumped on the right side? Is it clumped on the left side? Is it evenly spread? Is it clumped in the middle? You're going to go ahead and just describe what the spread looks like. Okay. Moving on to 7.3. And sorry, you guys, I'm going through this really fast, but I really want you to try a lot of this on your own. And so if you have extra questions, you can message me and I'll help you. But professional basketball players tend to be taller than professional baseball players. Here are 2 histograms to show the height distribution of 50 male professional baseball players and 50 male professional basketball players. Decide which histogram shows the height of baseball players and which one shows the height of basketball players. Be prepared to explain your reasoning. So take a minute, pause the video, think about which one you think is which and why, and then unpause it when you're ready. Okay, hopefully you took the time to really think about it. Let's look at the spread of our data. So on both of these, we have from 66 inches to 90 inches. And remember that in general, basketball players are taller. Okay, so one common mistake you might have made is to say that B definitely must be basketball players because of this data right here, because of this tall bar. But remember, what that bar is showing you is that a lot of these players are around 72 to 74 inches, which is kind of on the shorter side of the graph. Okay? Now, if you look at the data for A, all of this, the spread is kind of shifted more this way, more towards the taller side. And so you can accurately assume that this might be the basketball players because their data is more spread towards the right. They're generally more tall. And then even though this one has a big spike at 72, 72 is more on the shorter side. And so you can assume that this graph is of baseball players. Okay, write 2 to 3 sentences that describe the distribution of the heights of the basketball players. Comment on the center and the spread of the data. Okay, I talked about that a little bit, but go ahead and take what I'm saying and put it into your own words. So for the basketball players, the spread is clumped towards the right, which indicates generally taller players. And for the baseball, your spread is more clumped towards the left, which is generally shorter. And then basketball has less of a center height, which shows that in general there's more variability in heights. And baseball has a higher center, which shows that more of the players are around the same height. Okay, I hope that helps. That's pretty much the end of lesson 7, and I realize I went through it really fast, but if you have any questions for me, just send me a message and I'll get on Zoom and I'll help you out with that. I hope you guys have a great day. Bye-bye.